All right, please title your next page of notes, Radical Expressions and Exponents. Day 2, don't forget to include your page number. So the first thing we're going to look at is the cube root of 125 x to the 9th. And what I want to do is I want to split this apart to the cube root, and I want to rewrite the x to the 9th in rational form, and so my denominator is 3 because my index is 3. And so 125 breaks down to 5 times 5 times 5. And so you can group that. I need 3 of them in order to come outside the radical. And so that's going to turn into a 5. And so now with the rational exponent here, 9 divided by 3 is just x to the 3rd. And so my answer is 5x cubed. Alright, our next example, the cube root of x to the 8th times the cube root of x to the 5th. If my indexes are the same, then that allows me to combine the inside, and so this becomes x to the 8th times x to the 5th underneath the cube root, which becomes x to the 13th. And so now I need to simplify this, see how many groups of 3 I have. And so since I have a index of 3, what I want to do, and there's 2 ways you can think about this. You can do x to the 3rd times x to the 3rd times x to the 3rd, and keep going until you get to 13. So we have 3, 6, 9. So right now this is x to the 12th, and so I need one more x to make 13. And since this is a cube root, that would mean I could pull out 4 of these. And so this would be x 4 times, or x to the 4th. And then this x would have to stay on the inside of our cube root. So now instead of, if you didn't want to do it like that, if you're able to look at this and say, well, I know that this is going to break down to x to the 12th times x, because I need that 13, and then 12 divided by 3 would give us that 4. So if they have the same index, you can combine the radicand, or what's underneath the radical symbol. Alright, in our next example, we're going to look at the square root of x to the 6th times the cube root of x to the 4th. And here, since my indexes are different, I am not able to combine them like I did in this problem. And so I need to simplify them first. And so since this is a square root of x to the 6th, this is like saying 6 with an index of 2, so that becomes x to the 3rd. And then here, the cube root of x to the 4th, since this is only 4, I just write it out. I can have one group of 3, and so that can come out. And then the cube root of x has to stay. But now since these x to the 3rd and x are on the outside, now I can combine them to x to the 4th, the cube root of x. Now if you remember when we were doing IXL, we would have to worry about the absolute value bars, but for this worksheet, or these problems, we are just going to assume that all variables are positive, and by doing that, we don't have to worry about the absolute value bars. In IXL, we will have to continue to worry about them though. Alright, our next example, the 4th root of x to the 8th over 81. So when we are have a fraction underneath, we can rewrite it as the fourth root of x to the 8th over the fourth root of 81. So these two things are equivalent. And so now here I'm going to rewrite that because the 8 goes in, or the 4 goes into the 8 evenly. And so on top, that's going to become x squared. On the bottom, that 81, if you were to do the birthday cake, is just 3 times 3 times 3. And so I have a group of 4. And so I have x squared over 3. Alright, our next example has the fourth root of x to the 10th over 6. So like the last one, I'm going to rewrite it. And then on top, that x to the 10th, I'm going to rewrite as x to the 8th times x squared, because the 8 plus 2 will give me that 10. And then on top, if I do 8 divided by 4, that gives me x squared times the fourth root of x squared. Now the bottom, 6 only breaks down to 2 times 3, so there's not really anything I can do there. The problem is, if we remember, we can't have a radical in the denominator, so we need to get rid of it. So the way we do that is we rationalize our denominator. And so in the past, we would just multiply top and bottom by the square root of the radical of whatever we have. But if we think about this now, if I multiply top and bottom by the fourth root of 6, on the inside here, that's only going to give me 6 squared. And I'm not going to be able to take the fourth root of 6 squared. And so what happens is I actually need to multiply So now I have 1, 2, 3 6s. I have to do it one more time so that I have 4 6s on the bottom. So let's pause and look at this here. The reason I'm multiplying my 3 fourth root of 6 is so that now the bottom becomes, how many 6s do I have? 1, 2, 3, 4. So on the bottom, I have 4 6s underneath the radical. And what that's going to allow me to do, that's going to allow me to actually take the fourth root. And so now, that's going to become the fourth root of 6 to the fourth is just 6. So now here on top, they all have the same index. So that means I can combine them. 6 times 6 is 36, times 6 is 216. So this is going to become x squared, and then the fourth root of 216 x squared. Alright, next example. So we have the cube root of x to the 9th over 16. So like before, we're going to rewrite the top and bottom. And on top here, this is just x to the 9th, and write it as a rational exponent. So since this is 3, now it's just 9 over 3, which just gives us x to the 3rd on top. The 16, I'm going to go ahead and break down. So that's 2 times 2 times 2 times 2. And so there is a group of 3 that I can pull out. And so this is going to become 3, and the cube root of 2. And so now, just like in the last problem, I don't want to have the radical there. So if I multiply by the cube root of 2, so if we were to multiply these, I would only have 2 2's underneath. So I need to do it one more time. So now underneath the radical, I have 3 2's. So on top, this becomes x to the third, the cube root of 4. On the bottom, we still have this 3. And so now, I'll go ahead and write it like this. 2 to the third, because there's 1, 2, 3 2's. And so I can, which is just 8, but the cube root of 2 to the third is just going to become 2. And so this is going to be x to the third, cube root of 4, 3, and this here becomes 2, and that 3 times 2 becomes 6. That's where we'd have to stop. We can't reduce this because that 4 is underneath the radical, so it's protected. That's our final answer.